The rules, adding and subtracting. So again, like I said on the first day, when you're adding things that have the same sign, it's addition. You add the numbers, you keep the sign. And look, I gave you two nice little examples there. If you did -3, you spent $3 and you spent $4, you spent $7, all right? So I have examples. This rule works no matter how many numbers you have. If you have 3 numbers, 4 numbers, 5 numbers, as long as they're all the same sign, it's addition. I added 6, and then I added 11, and then I added 9, and I got 26, right? 11 and 9 is 20, plus 6 is 26. Now, if the signs are different, this is when you subtract them. But the thing is, you have to be careful how you subtract them. You have to make sure you keep the sign of the bigger number. So when I did -8 plus 3, I mean, look, if you owe me $8 and you pay me 3, you only owe me 5. Now, if you had $16 and you spent 2, oh man, I fucked that up. It's supposed to be a plus 14. Let's see. Oh, I'm not gonna be able to edit it. Oh wait, no, I can't. I don't think I can edit it right now. Is it gonna let me? Let me try. You see how I messed this up? It's because I copied the thing over and I forgot to change it. I don't know if it's, no, it's not gonna let me fix it. I'll fix this later, so don't worry. This is wrong. You have to keep the sign of the larger number, and that's a positive, right? So this should be plus 14. So there's an example of my stupidity. Multiplying and dividing. So look, the rules are different for doing multiplication and division. If the signs match, if the signs are the same, the answer is plus. So a negative times a negative, plus. A negative divided by a negative, plus. All right, so it's positive when the signs match. So again, you don't have to put this little plus there. You can just write 2, right? When you don't write the sign, it's 2. But I'm doing it for emphasis just to make sure you understand that it's positive. Now, when the signs don't match, when they're different from each other, the answer is going to be negative. So when you do a negative times a positive, negative. When you divide a negative by a positive, negative. Now look, I switched it. Positive over a negative, still negative. Signs are different. It doesn't matter whether the minus is on the top or the minus is on the bottom. It is irrelevant, okay? And then one last thing. Whenever you see this double negative thingy, when you see a -7, that's plus, because it really means -1 times -7. And remember, 2 wrongs make a right. I wrote a lot of numbers there. We discussed this a little the last time, and I made a point of telling you it's not a good idea to just try to do them 2 at a time. You can certainly do this, but it's going to take you longer, and it's going to increase the chances of you making an error. Now, first thing you do, you see this? This is what I was just telling you on the sign thing. These 2 negatives have to make a plus, so immediately make this +2. I'm not going to write the whole thing over again. Now, this is what I do. This is what I expect you to do. You're going to see your question like this on a quiz, and you'll see one like this on your test. And what I expect you to do is take all of the numbers that are positive and add them all together. I have 2, I have 9, I have 3, I have 8. No, I'm just going to try to add them together smart. I'm going to start with the big numbers first. 9 and 8 make 17. 17 and 3 make 20, and then 2. So I have a positive 22. So all the ones I use, I'm just going to cross them out. That looks like crap, but whatever. Now I have a bunch of negatives. So guess what? Add them all together. When they have the same sign, it's all addition. That's the point. I want to add. I'm going to add 5, 6, 4, and 11. 5 and 6 make 11, right? 11 and 11 is 22. And then 4 more is 26.
25.
You'll check this on your calculator, but I don't want you using one right now. I want to make sure you can do all this crap. So what do I do now? Signs are different. I subtract these numbers. I need the difference between 26 and 22. Well, they're apart by 4. And I keep the sign of the bigger one. So you can do this problem in 2 steps. 2 steps. You don't need to sit there and do these 2 and then these 2 and these 2, or just, go from left to right and like add those, and then that one, and then that one, and then that one. It takes too long. You're doing too many sums and differences, and the more you do, the more likely you are to make some type of a mistake, okay? So someone said it's blurry. Someone said it's clear. So it is what it is. All right, so I'm going to share the second note with you. Now, this is what we talked about the last time. First, I reminded you about the powers. I know you guys know how to do this. An exponent, I don't like the word exponent, but meh, whatever. So an exponent or power, it's that little number at the top. It's just how many times you multiply it by itself. This only makes sense if it's a whole number and it's positive. I will discuss with you what happens when it's negative and when it's a fraction. It's some crazy shit, but you do that in another class. So I just put some examples there. Now, here's the important part. When you have a lot of operations, you don't just mindlessly do whatever you see first. You have to do this in an order. This is why you have to be very careful with the PEMDAS thing. Parentheses do go first. If you see parentheses in a problem, whatever is inside of there, you do first. And then again, you have to follow the correct order. What's in there might be complicated, so you have to still follow the order. Now, the second thing, you do all the powers. Any exponents you see have to be computed. This is where we ran into, this is where we discussed last time that people F up. Notice that I wrote divide or multiply. I did not write MD, which, go ahead. Question? Don't be shy, tell me. Okay, so these operations are considered equal to each other. One of them does not take priority over the other. Look, exponents take priority over multiplication. If you saw multiplying in exponents, you have to do exponents first. If you saw adding and multiplying, you have to do multiplying first. But dividing and multiplying are considered to be equal. So you have to do whichever one you see first from left to right. This is important. I know a lot of people screw this up. They're like, oh, you got to do multiply. It's not true. You divide if the divide comes first, you do it first. Whichever one comes first. Now, when you've done the first three things, there's nothing left but a bunch of numbers with pluses and minuses in front of them. It's all adding and subtracting at that point. So you should do exactly what I did on the board, which was add all the positives, add all the negatives, and then subtract. I even wrote that there in the notes, okay? So it says, be careful about mindlessly following PEMDAS. All right, you should not just do this. You should not just mindlessly use this acronym, okay? You don't, it doesn't work. I mean, if you try to multiply before you divide and the division symbol was first, you're screwed. So look, if it went something like, because I have a lot of them here, so I'm gonna work a couple. If it was something like this, this is division. This should look better with this camera. I'm even throwing something extra in there. People are like, oh, multiply. This 4 times 3 is 12, and then you do 36 divided by 12. That's not going to work. Some people would do 4 times 3 and get 12, and then subtract 2 and try to do 36 divided by 10. That's not happening. You have to do this first. You have to do 36 divided by 4. Division and multiplication trumps subtraction. Subtraction is dead last. So you have to divide first because it comes first. It's just that simple. 36 divided by 4, you have to cut it in half twice. 18 and then 9. And then times 3, minus 2. Again, you're like, I'm going to do 3, take away 2. No, you're not. That's the wrong order. You have to multiply. So you have to get 27 minus 2. You're like, I can't do this without a calculator. It's like, don't worry. You'll be able to. Right now, I know something immediately that people want to do when they see this thing. You see this? I mean, I know from experience that people dive right in there and do 5 plus 2 and put 7 there. And then, you know, they go like this, which is wrong. Addition does not trump exponents. Exponent is higher on that list. So you must shut the power off. But wait a minute, I have a 2 out there in the front. Can't you do 2 times 3? Is that what you do? Maybe I do 2 times 3. This is hard because it has, like, you don't realize, but it has a plus, it has a times, and it has a power. It has an exponent. It's got 3 different things.
3 times 3.
Yeah, you got to do this power, right? So 3 times 3
9.
9. I'm going to keep it there in the parentheses. I missed my line. There we go. You have to shut the power off before you hop the fence. You cannot hop the fence with the power on. You have to do exponent powers before you do multiplication. It comes first in the order. So here you get 18. And then just add them together. This looks pretty scary. It's a little scary. Top first. I have a 5. 8 and 9 make 17. The question is, what do you do first on the bottom? Let's see. PEMDAS, or PEDMAS, however you want to say it. I mean, you have to do the parentheses, and there's only one thing in there, which is 12 divided by 4. So you have to do that. Once I do the parentheses, and I've computed what's in there, you don't need to write the parentheses anymore. 3 plus 3 is 6. Uh-oh. Now let's see, 5 take away 17. I have to subtract these numbers. I know that if I had 17 and I lost 5, it's 12, and I keep the bigger sign. What is 6 minus 6? Is it 1? Is it 1? I don't know what 6 minus. Oh, 0, 0.
0.
So the answer is 0 then. The answer must be 0. The answer must be 0.
No. It's negative 12.
Oh, it's negative 12. Let's see. Let's say I did 12 divided by 4, and I want to do my little division house. 12 divided by 4. Who goes inside the division house? Is it 12 or is it 4? Do you put the 12 in the house, or do you put the 4?
12.
You put the 12 here, right? And then you put the 4 there, and then you say, what times 4 is 12? Right, 12 divided by 4 is 3, yes? If you divided $12 among 4 people, everyone would get 3, right, evenly? So you needed 3 here, right? Because 3 times 4 is 12, right? Yay! Now the question I have for you is, what if I put a 0 here? See, the 12 goes in the house, right? But then 0 goes there. So you need something times 0 to make 12. Let's see, 12 times 0. Is 12 times 0 12? No. Is 0 times 0 12? No. Can you even do this? Can you multiply something by 0 and make 12? Think for a second how retarded that is. I'm trying to look at this and see what's there. Yeah, this is bullshit. You can't do this. You don't have to put the dots. I put the dots. This is BS. Division by 0 is not allowed. This is the reason it's not allowed. This is stupidity. You can't do this. How the hell are you going to do this? You can't multiply something by 0 and make a non-zero number like 12. So this is garbage. So we write BS. Now, it's supposed to be undefined or does not exist. BS. 2 letters. Bogus solution. Good enough. That's not what it stands for, but that's what you'll tell everybody else it stands for. So whenever you see a 0 on the bottom, this cannot be done. You write BS for me, okay? Now, on the other side, 0 divided by 12, 0 goes in the house, right? Can you multiply something by 12 and make 0? Three?
Yes.
What would that something be?
0.
Yeah, 0. Exactly. So 0, look, 0 on the top is cool. 0 divided by 12 is 0, because 0 times 12 is 0. But the other one doesn't work. You can't do 12 divided by 0, or 13 divided by 0, or negative 12 divided by 0. It doesn't work. 0 on the bottom is undefined. All right, this doesn't work. It's BS, bogus solution. All right, so you just eliminate it. Okay. So first of all, you want to treat this problem into 2 stages. You want to completely ignore this part temporarily, okay? And, you know, pretend that's not there. You want to focus on this dude first. First, like I said, we're going to ignore this part, which people can't see anyway. And I'm going to do just this part. First, I'm going to do the top and figure out what number I get and hope that it's divisible by -2. Now, the $1,000,000 question. This is either a +9 or a -9. And I'm curious how many of you think, so tell me,
I think it's -9.
how many of you think it's plus?
Positive.
Like, do you do -3, -3 and make it +9? Or do you do -3 times 3? So how many of you think it's plus?
I think it's positive.
Looking at the chat.
Positive.
We'll go back and remember this. So now this one meant -3 times -3. This one is definitely +9 because a negative times a negative is a positive. This one, however, you see, this negative is not being done to the power. It really is this. I can't do this negative to the second power. Here I can. This negative and 3 are attached together here. Here they're not. Here the 3 is getting the power. The negative is not getting the power. Here the negative is getting the power. So this one is -3 times 3, which is -9. Very easy mistake to make. This is very, very tricky. So you have to be very careful. So this is -9. Now, I have to erase that since, don't worry, it'll be there. I'm recording it. So now, again, I want to finish this number before I mess with this. So 5 take away 9. The difference between 9 and 5 is 4, and you keep the bigger sign. So it's -4, right? If you had $5 and you spent 9, you owe 4. And I have a -2 on the bottom. Now, one more time. I have to divide, and the signs are the same. This is like multiplication. Division and multiplication go together. So
It's 2.
2, +2. 4 divided by 2 is 2, and it's positive. I'm going to write the plus for emphasis. Now, do I really want you to multiply 9 times 7, 767? Do you really think I want you to do that? Is this the correct move to multiply that?
No.
You should be saying in your head, screw that crap, man. There's no way in this fucking world without a calculator I'm going to be multiplying that. Hell, even with a calculator, you get these ridiculously big numbers. What are you supposed to do first?
Subtract the inside.
Yeah, parentheses. You have to do this subtraction first. Now, I can multiply those, and they're both negative. A negative times a negative is a positive. Much easier, right? Do the inside, pow, get -1. 767, take away 768. The difference between them is 1. And he has a larger sign, so you get -1. Multiplying together, there you go. +2, +9, +11. I mean, this problem looks very hard and nasty and scary, but once you break this down and you break this down, it combines pretty nicely at the end.